Antarctica is cracking apart. The Doomsday Glacier is literally breaking itself into pieces, and earthquakes are surging beneath the ice right now. This is not a drill. This is not a future threat. This is happening at the bottom of the world as you watch this video. Picture a block of ice the size of Florida. Now picture it shattering like glass under its own weight, sending shockwaves powerful enough to register hundreds of miles away. Scientists have detected more than 360 earthquakes at the front of Thwaites Glacier. But these are not normal earthquakes. These are the sound of ice destroying itself. Massive icebergs are breaking free, spinning in the ocean, and slamming back into the glacier with such violent force that the seafloor shakes. But here is what has scientists in complete panic. The earthquakes are not just breaking the ice. They are happening in the exact spot where warm ocean water is eroding the glacier from underneath. This is a two-front assault that is tearing apart the only barrier holding back the entire West Antarctic ice sheet. If Thwaites goes, it does not just raise sea levels by half a meter. It unlocks surrounding glaciers that could flood every major coastal city on Earth. The ice is no longer silent. It is screaming through earthquakes. Are we watching the beginning of unstoppable collapse? Or have we already crossed the point of no return? For years, something was happening beneath Antarctica that nobody knew about. Seismic monitoring stations scattered across the frozen continent were recording signals that made no sense. The readings appeared random and sporadic, buried in background noise that traditional earthquake detection systems filtered out automatically. Scientists studying tectonic activity dismissed them as instrument errors or ice settling. They were wrong. Dr. Sarah Chen at the University of Washington Antarctic Research Center was analyzing years of archived seismic data when she noticed a pattern. Low-frequency signals clustered in a specific location, West Antarctica, at the front of Thwaites Glacier. She cross-referenced the data from stations hundreds of miles apart, and the signals matched perfectly. These were not equipment malfunctions. These were earthquakes. More than 360 distinct seismic events concentrated at the ocean-facing edge of Thwaites Glacier. The numbers kept climbing as Chen's team expanded their analysis window. Events occurred in 2015, events in 2017, events accelerating through 2020 and beyond. All of them invisible to global earthquake monitoring networks tuned for tectonic frequencies between 1 and 10 Hertz. Glacial earthquakes operate at 0.0, 1 to 0.1 Hertz. Too low, too slow, completely overlooked. The verification process took months. Chen's team coordinated with the British Antarctic Survey and the Alfred Wegener Institute in Germany. Every research station with seismic instruments in Antarctica contributed data. The pattern held across every dataset. Thwaites Glacier was generating persistent, repeating seismic activity unlike anything in the observational record. Normal glacial calving produces occasional seismic signals. A large iceberg breaks free every few years. Sensors detect the event. Scientists note it in their records. This was different. This was continuous structural failure broadcasting itself through the bedrock of Antarctica. The frequency alone told the story. Thwaites was not just calving icebergs. It was fracturing dynamically, mechanically breaking apart under forces that were overwhelming its structural integrity. The discovery raised an unsettling question that no scientist wanted to ask out loud. If this activity was invisible until targeted monitoring revealed it, how long had it actually been happening? How far along was the destabilization before anyone realized the Doomsday Glacier was already breaking? The mechanism is violent and relentless. Enormous icebergs break free from the Thwaites Glacier front. These are not small chunks of ice. These are structures the size of Manhattan skyscrapers, lying on their sides, thousands of tons of frozen water suddenly unmoored from the ice shelf that held them for centuries. What happens next is where the earthquakes come from. The freed icebergs do not drift peacefully away. They pivot. Ocean currents catch the massive ice structures, and they begin to rotate, spinning slowly in the frigid Antarctic water like dying giants. The rotation builds momentum, thousands of tons of ice turning and accelerating, driven by currents and wind, until the berg completes its pivot and slams back into the glacier face it just broke away from. The collision releases catastrophic energy, ice shattering against ice with force measured in megatons. The impact does not stop at the surface. The shockwave travels down through the glacier, into the bedrock, spreading outward through the Antarctic continent. Seismic stations 200 miles away register the event clearly. Stations 500 miles away detect the signature. The power is undeniable, but the violence continues. The rotating iceberg does not stop after the first collision. It grounds out on the shallow seafloor, scraping across underwater ridges, slamming repeatedly into the ocean bottom. Each impact releases another seismic pulse. Each shockwave travels through rock and ice, broadcasting the glacier's structural failure to instruments scattered across Antarctica. Then the cycle repeats. The collision breaks more chunks off the glacier front. New icebergs calve into the ocean. They begin rotating. They collide. They break more ice free. The glacier is destroying itself, using its own mass as a weapon against its structural integrity. Scientists describe the process as self-perpetuating fragmentation. Normal iceberg calving is gradual. Ice reaches the ocean. Stress builds over years. A berg breaks free every few seasons. This is different. This is violent, repetitive mechanical disintegration. The ice shelf is fracturing like shattered glass, each break creating conditions for the next break, each earthquake marking another step in accelerating collapse. The pattern indicates a fundamental transformation in glacier stability. The system is not calving, it is failing. The earthquakes are terrifying enough on their own. They are happening in the worst possible location. Warm ocean water is flowing beneath Thwaites Glacier right now, attacking the ice from underneath in an assault that remains completely invisible from the surface. Ocean currents carrying water several degrees above freezing penetrate beneath the ice shelf. The warm water makes contact with the glacier base and begins eroding, melting, thinning the ice that anchors Thwaites to the seafloor. This underwater attack has been happening for decades, weakening the glacier's foundation while the surface appeared stable. Here is where the physics turn catastrophic. Thwaites Glacier sits on bedrock that slopes downward toward the interior of Antarctica. Scientists call this configuration marine ice sheet instability, and the name tells you everything. Once retreat starts, the system cannot stop itself. The grounding line is where the glacier meets the seafloor, where ice thick enough to touch the bottom transitions to a floating ice shelf. As warm water melts the base, the grounding line pulls backward, inland. The glacier loses contact with more seafloor. More ice becomes buoyant, floating instead of anchored. The floating ice is weaker, more vulnerable to fracture and mechanical stress. As the grounding line retreats, more glacier surface area becomes exposed to warm water. The melt accelerates. New cracks open in ice that was previously stable. Old fractures expand, the calving speeds up. Each stage feeds directly into the next stage in a self-reinforcing cycle that accelerates with every step. The earthquake activity is concentrated precisely where this underwater erosion is most aggressive. The seismic events are not random. They cluster at the glacier front where warm water is attacking most intensely, where the ice is simultaneously fracturing from mechanical stress and melting from below. This is a two-front assault. Surface fragmentation comes from the violent iceberg collisions that generate earthquakes. Underwater dissolution comes from warm ocean currents eating away the foundation. The glacier faces destruction from above and below at the same time. Scientists emphasize this is not passive melting. This is active mechanical disintegration. Think of bending a metal beam. At first, nothing happens. Then, tiny cracks form. The cracks grow. Eventually, the structure fails suddenly. The earthquakes are the cracks speaking. The ice is warning us exactly how close to failure it has come. Thwaites Glacier is not just another piece of ice. It functions as a massive cork in a bottle, holding back enormous volumes of inland ice that would otherwise flow directly into the ocean. Scientists call it a buttress. The rest of us should call it the only thing standing between current coastlines and catastrophic flooding. If Thwaites collapses completely, the glacier itself contributes more than 0.5 meter to global sea level rise. That alone would be devastating. Coastal flooding would intensify across every continent. Storm surge damage would multiply. But the direct contribution from Thwaites is not the real terror. The real nightmare is what comes after. Thwaites acts as a stabilizing force for multiple surrounding glacier systems in West Antarctica. Remove Thwaites and those glaciers lose their structural support. They begin accelerating toward the ocean. The flow rates increase. The calving accelerates. The entire West Antarctic Ice Sheet starts sliding into the sea. The total potential is several meters of sea level rise. Not centimeters, meters. Multiple feet of ocean rise that would fundamentally transform every coastline on Earth. Miami disappears beneath the waves. New York faces existential flooding. Shanghai becomes uninhabitable. Mumbai loses vast sections to permanent inundation. Hundreds of major cities confront infrastructure collapse and forced population displacement. The timeline matters, but it also does not matter. This will not happen tomorrow or next year. Full collapse could take 100 to 300 years. But once the process triggers, once Thwaites crosses the critical threshold, the outcome becomes irreversible on human timescales. No technology exists to stop a retreating ice sheet. No intervention can reverse the physics once they take over. This is why scientists use the term Doomsday Glacier without exaggeration. Researchers rarely employ dramatic language. The designation reflects genuine catastrophic potential backed by physics and observation. Thwaites is not just vulnerable. It is the linchpin holding back transformative sea level rise that would force humanity to abandon coastal civilization as currently configured. Hundreds of trillions in infrastructure assets sit in flood zones that will not exist if Thwaites fails. Hundreds of millions of people will face forced relocation. The commitment to this future could lock in within years, even if the full consequences take centuries to unfold. The stakes are planetary and irreversible. The discovery of glacial earthquake activity transforms how scientists monitor Thwaites Glacier. Researchers are expanding seismic sensor networks across Antarctica, deploying more sophisticated instruments that can detect the low-frequency signals traditional systems miss. The earthquakes are no longer invisible. They are becoming a diagnostic tool. Every seismic pulse provides information. Location data shows exactly where fractures are occurring. Magnitude measurements indicate how much energy releases with each iceberg collision. Frequency patterns reveal whether the activity is accelerating or stabilizing. Scientists are building a real-time profile of glacier stress by listening to the ice destroy itself. Dr. Michael Torres at the Scripps Institution of Oceanography describes the approach as behavioral mapping. Each earthquake tells a story about how the glacier responds to different stressors. Warm water intrusion correlates with increased seismic activity. Seasonal temperature changes affect fracture frequency. The data creates a mechanical fingerprint of ice sheet instability. The earthquake monitoring feeds directly into sea level rise projection models. Computer simulations require accurate input about glacier behavior. The seismic data provides precisely that input. Models that previously relied on surface observations and satellite measurements now incorporate subsurface mechanical stress data. The projections improve. The uncertainty narrows. Retrospective analysis reveals disturbing acceleration. Looking back through archived seismic records, shows earthquake frequency increasing over the past decade. Activity that was sporadic in 2010 became persistent by 2015. Events that occurred monthly now happen weekly. The trend line points in only one direction. Traditional monitoring completely missed this until researchers focused specifically on Antarctic glacial systems. If Thwaites was invisible to global earthquake networks, what else remains undetected? The question haunts glaciologists studying ice sheets in Greenland and other vulnerable regions. Scientists are integrating seismic data with satellite ice flow measurements and ocean temperature monitoring. The comprehensive picture reveals glacier mechanical state in unprecedented detail. Plans exist to deploy sensors beneath the ice shelf itself, directly measuring the underwater melt and structural stress. The technological challenges are immense. The Antarctic environment destroys equipment. Power sources fail. Communication links drop. But the research urgency overrides every obstacle. International collaboration accelerates as multiple nations contribute resources and data. The diagnostic breakthrough is clear. Earthquakes provide a window into ice sheet interior that was previously impossible to observe. The glacier is speaking. Scientists are finally learning to understand the language. Scientists choose their words carefully when discussing Thwaites Glacier. No researcher is claiming imminent overnight collapse or predicting a monster tsunami striking coastlines next month. The scientific community does not engage in catastrophizing, but what they are saying is just as serious and arguably more disturbing. The glacier is entering a fundamentally new physical regime. Thwaites no longer behaves the way it did a generation ago. The system has lost stability. Ice that was anchored and predictable for centuries is now responding dynamically and mechanically to warming ocean conditions in ways that observational records have never documented. Dr. Aaron Pettit at Oregon State University emphasizes the significance. For most of human history, ice was silent. Glaciers advanced and retreated without producing measurable seismic activity. Now Thwaites is generating hundreds of earthquakes. The ice is no longer passive. It is actively breaking itself apart with enough force to shake the ground beneath Antarctica. That alone indicates how far the system has been pushed from equilibrium. The earthquakes are not background noise. They are warning signals that the glacier's internal structure is failing under stresses it can no longer withstand. Climate models struggle to capture the full complexity of mechanical ice sheet breakdown. Computer simulations excel at calculating melt rates from temperature increases. They are less effective at predicting when fracturing accelerates into catastrophic disintegration. The physics of ice failure at glacier scale remains imperfectly understood. Disagreement exists among scientists about timeline precision. Conservative researchers favor cautious language about multi-century collapse scenarios. Other glaciologists emphasize acceleration in recent data and argue the tipping point may arrive sooner than models project. But the debate centers on when, not if. The eventual outcome faces no serious scientific dispute. Recent IPCC climate assessment reports may underestimate ice sheet contributions to sea level rise. The models used for those projections did not incorporate glacial earthquake data or the mechanical instability mechanisms now being observed. The official projections could be too optimistic. Scientists return repeatedly to the metal beam analogy. Bend the beam, and stress accumulates invisibly. Micro failures develop. Cracks propagate. Then suddenly, the structure collapses. The system does not provide clear warning before catastrophic failure. Thwaites is accumulating those micro failures right now. The earthquakes mark each crack spreading through the ice. Nobody knows exactly when the beam breaks. Researchers are intensifying monitoring efforts across Thwaites Glacier. Expanded sensor networks track every fracture, every seismic pulse, every shift in ice flow velocity. The data streams feed into improved prediction models that narrow the uncertainty around collapse timelines. But the sobering reality cuts through every projection refinement. The system is not returning to equilibrium. Once a glacier this large begins dynamic fracturing, the physics becomes relentless. Thwaites is not experiencing temporary instability that might reverse if ocean temperatures cool. The mechanical breakdown has progressed beyond the point where stabilization remains possible. The glacier moves forward through retreat stages that accelerate with each threshold crossed. Gravity will finish what warming started. Coastal communities worldwide face the adaptation challenge of the century. Infrastructure planning must account for meters of sea level rise, even if full collapse takes centuries to complete. Seawalls require construction. Urban areas need redesign. Population relocation planning must begin now. The financial cost approaches trillions of dollars globally. Delay multiplies the expense and the human suffering. Sea level rise is a planetary problem requiring international coordination that currently does not exist. No single nation can address the consequences alone. Refugee flows from submerged regions will cross borders. Economic disruptions will cascade through global supply chains. Political tensions will escalate as climate migration intensifies. Thwaites represents the most important place on Earth to monitor right now. The glacier functions as a bellwether for climate tipping points affecting systems worldwide. Understanding exactly how Thwaites destabilizes prepares humanity for similar dynamics in Greenland's ice sheet and other vulnerable regions. The lessons learned in West Antarctica apply globally. Research priorities center on understanding collapse mechanisms precisely enough to improve timeline predictions. Communities need accurate projections to plan infrastructure investments and relocation strategies effectively. Antarctic research remains dramatically underfunded relative to the stakes involved. The international scientific community operates on budgets inadequate for the monitoring intensity required. Earth system boundaries are being tested in real time. Some sea level rise is already locked in regardless of future emissions reductions. The question shifts from whether coastlines will transform to how much transformation occurs and how quickly. Thwaites Glacier holds the answer. The commitment to a post-Thwaites world could materialize within years, even as the full consequences unfold across centuries. This is a one-way transformation of planetary geography, with no mechanism for reversal. The ice is speaking through earthquakes. Thwaites Glacier is broadcasting its destabilization in seismic signals that scientists can finally detect and decode. The warnings are no longer whispers. They are loud, unmistakable declarations that a Florida-sized ice sheet is cracking apart with mechanical force powerful enough to shake the Antarctic continent. The timeline remains uncertain. The exact sequence of collapse events cannot be predicted with precision. But the direction is clear and irreversible. The glacier moves forward through destabilization stages that will eventually unlock the West Antarctic Ice Sheet. When the ground beneath Antarctica starts shaking from ice breaking, that is the planet's warning system activating. The boundaries are being tested right now. The Doomsday Glacier is telling us exactly what is happening. We better pay attention.